Okay, question 7 is a tech active question. So the heights of all the students at the school were measured to be a mean of this and was calculated from this data. A random sample of 35 students from this school was selected. The mean height of the sample was this, with a standard deviation of that. The smallest confidence level that could be used to produce a confidence interval that includes U based on this sample is, and then we're looking at these 4 answers. Now, in order to resolve this question, I updated my computer and it's changed where everything is, so today's going to feel a little clunky. So first thing I'm going to do is note down the important information now that I've read the last question. It's always important with confidence interval questions to make sure that you read the end first, because otherwise sometimes the question doesn't ask you to actually solve for something, it's just asking you for general knowledge. Okay, so first piece of general knowledge that I'd like to remind you about. If I have something that looks like this, let's say in there is 90%, or it's got an area of 0.9. Now, if this correlates to z-scores of, let's say, negative 1.64, and this is 1.64, if I want to test whether or not something is going to be included in the sample, I need to make sure that it's within this range. Okay, so that means I can go larger to make sure all of those values are still included. But if I go smaller, then I might be missing some of those values. So we want to go larger. Now, for confidence intervals, to get that larger band, we increase the confidence. So if I increase the confidence to 0.99, obviously to be more confident, I have to include more of these values. Okay, if I was going to be less confident, then I could decrease the interval to include less of the values. Okay, so that's the basis of what we're working with here. So let's start noting down the important information. First things first, the mean of this sample. The population mean is 157. A random sample of 35 students. The mean height of the sample was 159.7 centimetres, and it had a standard deviation of 8.7 centimetres. Now, when we're talking about standard deviation, remember there are 2 different ones. There's standard deviation that we use alongside the raw scores, and there is the sample deviation from the means. So that's the one that we use as S. So we don't want to use that one. This is referring to each of the individual scores. That's why it's the deviation like that. Okay, so if I want to make sure that this value is included, that means I want it to be in this bar. Okay, now it could be a little in the, well, actually, if it's the mean, it is dead center. So 157. If the mean height of the sample was this, then we're saying that we can deviate left or right by 2.7 scores. Okay, because the difference between these 2 numbers is 2.7. So I can say that the error, remember we calculate our error formula using the one from the formula booklet that looks like this. So if this is our confidence interval, then this is our error portion here. So we want 2.7 to be equal to z, and it's the standard deviation over the square root of n. Okay, so 2.7 is equal to, now we don't know what the z-score is. That's what we're actually trying to find here, is we're trying to find these scores along the bottom. But I do know that the standard deviation of this is going to be 8.7 divided by the square root of 35, because 35 people in the trial. Now, in our calculators, we can solve n for this instead of doing any of the hard work. So, options, calc, solve n, 2.7 equals, so shift equals x bracket fraction 8.7 over the square root of 35, And then we're going to do comma X. Remember, if you don't do the comma X, sometimes weird things happen. So comma X, close your bracket, execute. Okay, and now we're going to press fraction to decimal, and I'm going to get the answer of 1.836. So Z equals 1.836. Now, if you're thinking about what this looks like now on our thing, for it to include those scores, it will have to be 1.836 and negative 1.836. Now, it's asking us to find the smallest confidence level that could be used to produce this. So now I'm trying to find the area between these two things using my z-scores. Now, if we're using z-scores, that means standard deviation is 1 and mean is equal to 0. So I'm going to go menu, across. It is normally distributed, and if it was asking me something about whether or not I could tell that this thing should be normally distributed, your sample is above 35. Sorry, it's above 30. So whenever it's above 30, it's large, or large enough to say it's normally distributed. Okay, so now we're going to go lower, negative 1.836, execute 1.836, execute, mean is 0, standard deviation is 1, execute, and that gives me a probability or an area equals 0.9336 if I round to 4 decimal places. Or I could say the probability of that is 93.36%. Now, what we were saying at the start is what we're going to go back to. So remember to make sure that these values are included in our confidence interval, we have to make sure that we're going larger, not smaller. So I have to pick the number that is larger than 93.36. So that would be, this one is the closest to it, being slightly larger, but not the largest. Technically, 99% would also include those values, but that is the one that we're looking for. The one that's closest to it, but not the largest of it.